Hello. Today we're going to be solving the Leetcode problem 2357 of making an array 0 by subtracting equal amounts. Now this is given that this is an easy problem, but to me personally it was a bit of a challenge. But let's try to get to it. So you're giving an array that has non-negative values, so you're going to always have positive values, and the array is called nums. Now the rule is in this solution that you need to include. You need to choose a positive integer of x, and this value of x needs to be less than or equal to the smallest non-zero element in nums. So it needs to be greater than 0, and it needs to be the smallest value in the array of nums. Once we find the minimum, we can subtract with every single positive element, basically non-negative and non-zero in nums, and to subtract it by nums of every element in nums. And then we're gonna basically keep a counter of how many steps it took us to get from the current nums into basically having 0. And this is what it's requesting us to. So return the minimum number of operations to make every element in nums equal to 0. Now, we can take a quick look at this example, 15035. When you first look at this array right here, you can see that the minimum number here is 1. So the first step is to use 1 subtracted by itself, 5, 3, and 5, which results into 0, 4, 0, 2, 4. Now the minimum is 2 in this step right here. And since we have 2 right here, we need to subtract everything by 2, which results into 4 being 2, 2 being 0, 4 being 2. And that's step number 3 right here. And now we subtracted again by 2, so now we're 0. And this results into 3 operations it took in order to get to this state. Now, I have a solution that I think was a bit more intuitive and requires less algorithm implementation, really. So let's jump to the whiteboard and talk more about that solution. So going to the whiteboard to throw out the theory of the solution that I'm going to be discussing here shortly. The example that I'm trying to demonstrate here is going to make a lot of sense to what I'm trying to say, hopefully. So let's say we have this array. Please excuse my number 2 here. Array of 1, 1, 2, 2, 2. So this, you can see here, it's equal to 6 elements. Now, how many operations would it take to bring this down to 0? According to the previous example we looked at in Leetcode. Now, if you guessed 2, you're right. It takes 2 operations to get down, so you subtract this by 1. So that's the first step. You're down to 1, 1, 1. And then we're going to pick the minimum again. It's going to be -1 and 1 and 1. 0, 0, 0, which goes here. So the amount of steps that it took is 2 steps or 2 operations in order to get into nums equal to 0. Now, what I'm trying to even draw your attention here to, let's do another example. Let's say we have an array of 1, 1, and 1. How many operations would it take in order to get to 0? I'll take 1. And even though we have 3 elements, we could have 100 elements here. It doesn't matter because the numbers are the same. And it'll only take longer times in order to hit this point, increase the amount of steps, is the diversity in the numbers in the list. So how many unique elements do we have? So going back to this example, we have just drawing this up. So we have 2 elements that are unique. And how many operations did it take again to get to 0? It only took 2. Because there are only two unique elements that we need to handle in order to get to 0. Nothing more, nothing less. So if we can find a way to create this list of unique and returning its length, that would be our answer. So getting the length of unique is going to be the number of operations it takes for the array to be 0, 0, 0. And what I'm trying to allude to here is that we're using something called a hash set would be able to allow for this to happen. Now, if you don't know what a hash set is simply a data type, a data structure that can only account for unique values without any care of the order they're in. Now, that last detail doesn't really matter for this problem, but in case if you ever were to use it again, it's something to keep in mind. So given that we're going to be using a set in order to keep track of unique elements in nums, and then we're going to be returning the length, that is what is going to be the driving force in order to get this solution down. So given that, let's jump into Leetcode and try to code this up. All right, going back to Leetcode to code up the solution. So let's go ahead and start. Before I even get to the logic of the solution that we discussed in the whiteboard, I would like to just write up the quick check here. If nums is none, what this is basically saying is if the array is empty or the values are 0, then we would like to return 0, just so we can save our time with compiling. This is also a good habit to have in case you're coding up in the real world. It's a nice thing to always account for. Now, let's create the unique list and setting up the set itself that we discussed earlier, the data type, the data structure. And now we're going to create a for loop, and we're going to be looping through the nums and checking if it's a unique or not, basically. And it's also the value needs to be a positive non-zero. So for num in nums, if num is greater than 0, and num is not in unique list, I would like to add this into the list then. And the way to add value into a set is basically use the command add, and you go num. Then we would return the length of the unique list. Now, in reality, you could have just created another value and said, count plus increment by 1 and have it out there, define outside the loop. And that would work fine and return that instead of the length. But I just thought, since we don't want to use any more variables and make this complicated than it really should, we just return the length of the unique list. So let's run that real quick. As you can see here, it has passed all the test cases, and let's submit this. And the runtime is pretty acceptable. Memory usage is normal here. And by the way, the time complexity here is O of n. Time complexity is O of n. Since we're only looping once and we're using a set. But space complexity space complexity is going to be O of n as well, since we are creating a list. Oops, sorry. I can type anyway. Jeez. Sorry. So space complexity is also O of n. Since we're not, modifying the list in place, we are actually creating another list, and we're using more memory to do that in order to do so. And that's dependent on the size of the array that we get. So yeah, hopefully that was helpful. If you find that pretty helpful, go ahead and leave a like. And if you have any questions, please leave in the comments. I'll be more than happy to address them. Thank you so much and have a good day.